In problem number 18, we are told that a football team plays 10 games, and we want to know in how many ways can these games result in 5 wins, 4 losses, and 1 tie. So let's make this count. First of all, let's get the 5 wins. So we know that there's going to be 10 games. So since order doesn't matter here, out of those 10 games, we want any 5 of them to be wins. And then after we have the 5 wins, let's get our 4 losses. So we're going to have, now we want 4 losses, but we've already played, there's 10 games, we've already played 5, so 10 minus 5, there's 5 games left. And out of those remaining 5 games, we want 4 of them to be losses. Now, altogether, we've played 5 games and 4 games, won 5, lost 4. So there's 1 game left, and we want that one to be a tie. So here's our answer right here, and if we compute it out, in problem number 22, we've got 15 calculus classes being offered by the mathematics department, and we want 5 of them to use graphing calculators, 4 of them to use computer software. So let's count the number of ways we can make this happen. Now I think this problem here is going to be very similar to this problem up here in this sense. Okay, out of those 15 calculus classes, we could choose any 5 of them to use graphing calculators. Now we've assigned 5 of those 15, so there's 10 left, and out of those 10, we want 4 of them to be taught using computer software. And now altogether we have we've assigned 9 classes out of those 15, so that means there's 6 left. So let's say then that out of those 6, we want the 6 to be taught I guess, the regular lecture way. So there's our result. And if we compute that out, when I computed that out, I got 630,630. In problem 27, we are told that the student council at Gotham College is made up of 4 freshmen, 5 sophomores, 6 juniors, and 7 seniors. And what we want to do is take a photograph of them lined up so that each group of classmates stand together. I'm taking that to mean that we want all the freshmen standing together, the sophomores, the juniors, and the seniors, but not necessarily in that order. So our first count should be, which class do we want on the leftmost? Now we have 4 to choose from, so we have 4 ways to make that choice. Then, who's going to be just to standing next to them, to our right, their left, and we have 3 classes left, that's going to be 3, and then there's 2 classes left, and then 1, so that turns out to be 4 factorial. So there's 4 factorial ways to arrange the classes. So let's write our 4 factorial, and then what we'll have is, once we have the class, how many ways can we arrange the students in that class? Well, since multiplication is commutative, it doesn't matter what order we put these in, but there's 4 freshmen, there's 4 factorial ways to make those arrangements, 5 sophomores, 5 factorial ways to arrange those students, 6 juniors, 6 factorial ways, and then 7 seniors, 7 factorial ways. So this is really our count, and if we actually compute that out, that comes out to, well, I got 870, and then 912, and then 3 zeros. In problem 28, we're told that a truck driver has to deliver bread to 5 grocery stores. How many different ways can he schedule the order of his stops? Well, when he starts looking at how he can make his stops, he's got 5 ways to make that first store, and then 4 for the next, then 3, then 2, then 1. This just looks like a 5 factorial, which we know to be 120.